So here we are again. For me, this is about an hour after our live lesson. So because of that, I want to recap 5.1 slightly. So again, one vibration is whenever you are back at the same part. Dus in dit geval dan heb je een bepaalde herhaling. En every time when you come back here, the same movement starts again. Every time you start over, we call that a second, in Dutch we call het herhaling, in English we call it a new period, een nieuwe periode. We use this to calculate frequency. So the periode, in Dutch trillingstijd, how long it takes for one vibration to play out. And again, it's one time it goes up and down. That's één trilling, that's one period. If you know the period in seconds, you can calculate the frequency. So if you know how long one period takes, you can calculate how many of these vibrations you can have in a single second. The unit for vibrations per second is called hertz, and we call it the frequency. So when you measure the frequency, you measure how many vibrations there are every second. If the frequency is very high, dan noemen we dat een hoge toon. If the frequency is very low, we call it a lage toon. You measure you calculate by using the following formulas. If you know how long a certain vibration takes, if you know the period, you divide 1 over t. If you want to know the frequency and you want to calculate the period, you do 1 over f. For example, we can do it in this example. We're going to do this example. Remember that every second is 1,000 milliseconds. So if you go from seconds to milliseconds, it's times 1,000. If you go the other way around, it's divided by 1,000. You also sometimes need kilohertz. 1 kilohertz is 1,000 hertz. So from this diagram, you need to determine the period, hoeveel lang duurt één trilling, and calculate the frequency. So één trilling, one period, is between these red lines. What you can hopefully see is that this segment repeats itself every time. And because it repeats itself every time, we say that the vibration is repeated. And every time the vibration repeats itself, it's a new period, a nieuwe periode. So between these red lines is a single period. It starts here and it ends here. So one period takes about 30 milliseconds. 21 minus 8. The period we always give in seconds. So we need to divert this 30 milliseconds to seconds. So we divide by 1,000. So we get 0.013 seconds. Now you can fill in the formula. The frequency is 1 over the period. 1 gedeeld door de periode. And therefore it's 1 divided by 0.013. You get a number that is around 76.9. This means that this vibration, because it's so short, it can repeat itself almost 77 times within 1 second. This basically means 76.9 vibrations each second. And we use the abbreviation, the afkorting, hertz, HZ. So this is what you had to do last time. Now we're going to look into the new stuff, so the understanding 5.2 and also the calculating 5.2. We're going to look at speed of sound. But first you need to know the 3 requirements for sound. You need something where a sound starts. We call that the source. And this could be anything that vibrates. So it could be a speaker, but it could also be your throat. You need a receiver, so something that collects the sound. In our ears, there's something we call the slakkenhuis, the cornea, the slakkenhuis, and in it there are like small hairs. They vibrate with the sound. And we also need something that transfers the sound from the source to the receiver. And this is we also always call a medium. So for propagation, sound goes away from the source and then it uses a medium, in Dutch a tussenstof, which also vibrates according to the source. So it could be air, it could be water, it could also be a metallic or surface. It could basically be a lot of things. Some mediums, they carry sounds better than other mediums. you cannot transfer sound through a vacuum. So if you would have this bell, if you put it in a vacuum pump, then you cannot hear it, because with this vacuum pump you can suck out all the air, and because there's no air around this bell, you will not hear it. The same goes in space. So every movie you see where you hear sound in space is basically BS, because it cannot be true. In space you hear nothing, because there's nothing around you that can propagate sound. There is no air, there are no particles there. What you can also hear is an echo. And an echo is whenever you produce a sound. So let's say you produce a sound yourself, you talk forward, but then it hits a wall and then it is bounced back. When you do, you call this an echo. So there's always a delay somewhere. But that means that sound has traveled away from you and also back again. Now we're going to do some calculations. This is, by the way, part of the homework for this week. We're going to calculate speed of sound. So for instance, when you have this echo, like I said, you have a place where it starts, a source. In this case, someone claps. The source goes away, the vibration goes away from the source towards the wall, and here the sound is reflects back, and then it goes to this receiver, which in this case is a microphone, but when you are talking, your ears are also the receiver. So this is, you are both the source and the receiver. What we use for this, we use a formula we already used before. We use a formula that can use distance, velocity and time. So it's basically from chapter 4. What you need to know is that speed in the air travels with a certain speed. So the speed of sound in air at 20 degrees is exactly 343 meters per second. This means that whenever you hear a sound, it takes, whenever a sound is produced, it takes a full second to travel 343 meters. This is why as a kid you probably remember that when you see lightning, that it takes about 3 seconds for you to reach it. That means that the lightning is at least a kilometer away. For every second it travels 343 meters, so 3 seconds is about 1,000 meters, so it's about a kilometer. So that's correct. When you want to calculate this, you need to use the following formula. So the speed of sound is the distance divided by time. Again, just like last chapter, you need to rewrite it. So the distance is velocity times time, or time is the distance divided by the velocity, the speed. For example, we have an echo and the chamber is 56 meters deep. How long does it take for you to hear this echo? So this is a typical example of like a test question. So when you hear, when it means that the echo chamber is 56 meters deep, the sound has traveled both in the chamber but also back again. So that means that the total distance that the echo has traveled is twice as big. Again, it goes in and back to you. So whenever the chamber is 56 meters deep, it means that the sound has traveled twice as much, 112 meters. The speed of sound is a given. It is 343 meters per second, at least at 20 degrees Celsius. So you can calculate time. When you rewrite the formula, time is distance divided by the speed. So the amount of time it takes for the echo to come back to you is about a third of a second, 0.327 seconds. And this is basically what you need to do this week. I'll put extra question on the board, but for now you can work on this homework. Good luck!